Hello hackers, I'm Andrei from ZkNoid project, and today I want to introduce you how you can build your own game using ZkNoid SDK. ZkNoid was built on a hackathon with the idea to unify all the gaming on Mina ecosystem. We saw different attempts to build games on Mina, but they didn't succeed. The problem is, to build even a simple game, you need a lot of infrastructure stuff. We wanted to build an infrastructure provider, so games developers don't need to implement their own layers, just plug in the ready ones and launch their game. ZkNoid is represented as a GitHub repository. It can be found using this link. So here is the core of ZkNoid. Here you can see all the infrastructure layers, all of the games, smart contracts and frontend. Here is a description on what is ZkNoid. You can read it if you're interested to learn more about ZkNoid. Here are the steps to set up all the infrastructure locally. First of all, we need to clone this repository. We run command git clone in our terminal. I'm opening my terminal and entering this command. So it's cloning the project to the local directory. Here we need to wait a bit. Now we have our repository cloned. The next step would be to change directory and open the ZkNoid folder. We'll type this command in terminal and we're in the ZkNoid directory. Here is the important command that ensures that you have the right Node.js version, because if you have the incorrect one, the project build may fail and you may be wondering why. So it asserts that I have the correct Node.js version. The next step is to install dependencies. For this, I run the npm install command. Now I have all my dependencies installed, and here is the core command that launches the entire game store. I can see that frontend is launched on this address, and then local sequencer is setting up, so frontend could interact with it. I need to wait a bit until all the modules are initialized. And now we are moving towards our game store. We have this address and we are opening it in browser. We need to wait a bit until it's compiled. Now we have our game store. On the store you can see the games listed. When you develop your own game, it will be listed here as well. So to check that all works fine, we can open a test game, for example a Renzo game. Let's try to make several transactions in game to make sure that all works fine. In the game we have the default matchmaking options. That means that they are initialized on chain. For example, we can create a new lobby here. We're typing the random name, typing create lobby button, and making a transaction. we can see the lobby in the list, so our transaction executed successfully and the local version of the ZkNoid Store works fine. So now we launched the ZkNoid Store locally, and now let's overview the architecture of the ZkNoid. Let's return to the guide. The second concept I need to introduce to you is the upchain. Upchain is the local network that have some predefined set of contracts that are identified by names, not by addresses. This is like a local network. When you start the ZkNoid Store, it's launched and it contains only the predefined contracts. Let's overview ZkNoid file structure. So we have some interesting places in the store. Here we can see apps, web, games directory. This directory contains all the frontend for the games and configs. You can see this config.ts file. This file registers all the games that are listed in the store. So you can see all the configs of the games are registered here. When you launch your own game, you need to implement your own config and register it here as well. Let's overview config of one game, like Renzu game. Renzu game have the following config. In the config we define ID of the game, type of the game, name, description, image, and other useful features for the game. One important thing here is runtime modules. Runtime modules are the contracts that are used by the game. It allows to initialize the on-chain part and to add the smart contract for the frontend, and when you create approvable games, your runtime modules or upchain smart contracts needs to be registered here. Also, the page is exported here. The page is a React component actually that is rendered when you open the game. And also lobby component is exported here. I will share later how it works. The second interesting part in the ZkNoid is the chain package. In this package you can see the src directory, and in this directory also there are all the directories for all the games. For example, you can open the Renzu game, and here you can see Renzu logic.ts file that is actually a smart contract for Renzu game. You can see the index.ts file that exports all the types we need from the smart contracts file. Also, in the chain package, we have the global index.ts file. This file exports all the smart contracts for the games, and when you build your own smart contracts, you need to export them here in order to use from frontend. Now it's time to implement our own game. We will implement a simple number guessing game in that one player hides a number and second needs to guess it. We already covered the creation of the smart contracts for this game in one of our previous articles. So for now we'll reuse the contracts we already implemented and we'll connect them to the ZkNoid framework and build user interface. To achieve this, we'll create a game directory in the packages chain src directory. So we type new folder and we'll name it guessing game. Here we can create a file, name it guessing game.ts. In this file we'll store the smart contract we already implemented in previous article, so I'm going to open the tutorial and it's mentioned here. We can find the smart contracts file here, ZkNoid. If you're interested how we implemented it, you can open a previous article in our blog ZkNoidMedium.com, and you can find the implementation process of the smart contracts. Now I will just open this smart contract and copy it. Now I will create the index.ts file and I will export . Now I exported the smart contract. Now let's open the smart contract itself and see that VS Code highlights the errors here. That's true because our contracts need to be adapted to be used on the app chain, not for the mini mainnet. Let's see the adoptions we need to make. They described fine in the article. So our contracts are written for Mina layer 1 and we need to adopt it so they can be used with our local app chain. So the first change is that we should use runtime models instead of smart contracts. So in Mina we have the following definition: class extends smart contract, but here we need to extend runtime model, and also we need to provide the config for the runtime model. So we'll use the one from tutorial. We'll create an interface number guessing config that will be empty because we have no config requirements for the model, and we'll extend the runtime model with this config. So we'll extend runtime model here. We need to restart TypeScript in order to make the imports work. So we import this thing and we create interface for our config with gem config. Let's say it this way. And we inherit the config here. So our first modification is made and it's no more highlighted with error. The second thing we need to change is the adding of the decorator. All the runtime models should be decorated using runtime model decorator. It looks like this. We type the add symbol and runtime model and importing it from protokit model. Now we decorated the smart contract. The third step would be to make the state variables correct. In protokit, state variable initialization looks differently than in Mina. So here we can open the guide and see how we can change the state variables. So in Mina we use this definition, in AppChain we need to use this definition, and we need to import state correspondingly from protokit protocol. We add this import and remove the import from O1.js. Here we use state from here and removing the imports from O1.js. So here we have the state, and here we need to change the definition to this one. State from the type and the time passed to the arguments. State from the type and the type passed to the arguments. Also, we have no constructor here, we shouldn't call this. The next part would be to adopt methods. We have no method decorator in AppChain, but instead we have the following decorator: runtime method. All the methods should be marked as runtime methods to be registered on the AppChain. So we are changing all the methods this way. The next modification would be to change get and require equals. ProtoKit solves the data inconsistency problem, and we don't need to require equals, and we can just type get here. But we need to add a wait here, because gets and sets are promises and we need to avoid them. So we are changing all the get and require equals and adding awaits. The next modification would be to change the approach of dealing with asserts. On AppChain, we are not going to fail in smart contracts because we have several tracing passes, we have the contract simulation, and we don't want to fail on some basis while executing the smart contract. So we should prefer the soft asserts instead the hard ones. Soft assert means that code execution won't fail, just it will be registered that smart contract had failed while executing. So we need to import assert from ProtoKit and use it instead of assert equals. So here we type assert and the condition. Here it would be that value of hidden number is equals to the 0 field. And we'll copy the error message. And here as well, we'll use the soft assert that hidden number value is equals to the hash of the number. And also we'll copy the error string. The next change would be to change the way how we interact with maps. In Mini protocol, we use Merkle witnesses and Merkle trees to deal with some key value maps. Because you can store a lot of data on smart contract, and we prefer to store the key value map in off-chain and only change the root, providing the Merkle witness that we can change the data. However, in ProtoKit we have a handy wrapping around this approach. It's called state map. So for storing the scores of the players, we can use the state map instead of a Merkle root storing. Here we can create a state map from score, so we'll call it just score and create a state map here. The state map consists of two types, the key and the value type. In our case, it will contain the pairs of the address of the player and the score amount. So we use first type as public key, it's the address of the player, and the second would be the numeric type. Let's take this one. We'll import it from protokit library. And we need the same types in the arguments of the initializer. We don't need init function here because the state map is initialized by upchain. It's not our work to initialize the zero root for the key value map. Let's change the approach how we work with the score. We used to update it using the Merkle witness, but instead we'll use this approach. We'll use score and just get. And now we have the score from the smart contract. It's a lot more handy than dealing with Merkle proofs and Merkle witnesses and storing the information off chain. So we'll store the user score in the variable and add a weight here. And we'll take the score for the sender. We'll use call this transaction sender value, and we got the user score here. And also we don't need this part because we don't need to reconstruct any witnesses, and we can remove this part. Here we can set the score for our player, and we need to also add a weight here, and we'll set the score for the player. Here is the player, the current address, and the user score. We need to modify the user score, so we need to add 1 to the score. This means that user guessed the correctly. And for the simplicity, we'll create the new user score variable that equals to user score value at 1. And we'll set the new user score here. I missed the last two things here, I guess. Here are the awaits for the set functions. So set function is a promise here, and we need to await here and here. Also, here is an unused stuff I haven't removed. We don't need this thing as well. And also, we don't need to provide score and score witness because it's managed by upchain, and we don't need to reconstruct the proof, so we just remove it. In the contract, we haven't fixed the following things. We still have the hard assert here, so we're going to change it to the soft assert. We'll add assert here that number is less than field 100, and we'll copy the error message here as well. Now we have our smart contract ready, and we need to export it from the chain package. To do this, we need to move to the index.ts file and make something like the export from similar game, for example. We need to export all from guessing game. One more step is that we need to register our runtime model in the runtime TS file. We open package chain runtime TS file, and here we register our smart contract. We use import from guessing game, the guess game contract. We register it in the our protokit config, and we add it to the list of the models. This step is important because if we don't register it, it is not presented on the app chain and we can access the smart contract. Now our contracts are completely ready and we can move towards the front-end building to wrap up the contracts and create a game with some visuals that you can share with your friend and play in real life. Now let's move to the front-end building. To build the front-end, you need to open the following directory. It's located in the apps, web, games. Here you need to create a directory for your game front-end. We click new folder and guessing game. To register our new game frontend to the store, we need to create a config for our game. This config describes all the information about game and exports the game component that will be rendered when you open the game. So I click a new file here and create a file named config.ts. Here I will copy a config for other game, for example from Renzi game. Here is the config. I need to rename it to the guessing game config. I need to change ID. I think the type is the same, PvP game. We need to change name. We need to change the description. The description is one player hide a number and second player guesses it. We need to change image. Let's try the default soon image that will show that game will be realized soon. It's a logo mode that defines how the logo is displayed in the store. You can place it on the center, you can make it the container white, so option is defined here. We need to change the genre. It's lucky game in our case. We need to review the features. I think it's a multiplayer game. It's release date. I can change the author to the Andre, and rules. In rules I will copy for now the description. It suits the best. Here are runtime models, so we need to define the contracts we use for the game. We already implemented the contract, we need just to import it. It's a guess game contract, and we define it here. And now we have no errors. Sometimes it requires a bit of time to load all the packages for Visual Studio. And here the next element of building the front-end is defining the page. I will remove the lobby here now and will focus on the page. The page defines the component that is rendered when you open the game in the store. So we need to define our own component. Let's create the component file. We'll name it getGameComponent.ts. We'll export a simple component. We'll return the empty component from it. I think I need the T6 file, not the TS1. Yes, we defined our own component and now we can register it in the config. We place the component name here, import it, remove the old import, and now we have our config set up. Now we need to register this config in the global config. So we copy the config name, move into the global config, it's located here in the web games config. And we register the new game config here. We are adding the import, and now the config is registered in the store. Now we can launch the store and we could see the new game in our store. We open terminal, we are running this command, and local sequencer is launched locally and it should use the new game. Waiting for the loading to complete. Now we have our store launched locally, and now if we scroll to the bottom, we can see the game we just created. It's multiplayer-like, just like we defined in the config. Here we tap on the game and see the black screen. That's because we haven't implemented our React component for the game page. Let's return to the game component. For the component implementation, we'll follow the guide in our Medium blog. First of all, we need to create the asset for the game cover. We can take this asset using this link. So I just download this file. And copy it to the assets directory and place it here. The component itself I will copy from the same article. We can find the component in the bottom. There are an overview how we can build the component by ourselves, but here is the full code for the component. I will copy it and make a small overview. So I just copy it and paste here. We need to change the config name. We named it guessing game config. I'm changing the config name to make this all work. So let's have a brief overview of the component. So here are the state variables that store all the data we need on our page. Here is use context. This context is provided by ZkNoid, and Upchain client can be accessed using this context. We use stores provided by ZkNoid, the network store, the protected chain store, and toaster store, allowing to send toasts on the website. Here we add the Upchain client from the ZkNoid context. We create the query for our game. We create the function to hide a number. This function uses the client runtime to make a transaction, and transaction is signed and executed. The same one with guess number. It uses the guess number function. We have use effect to read some data from state. In this use effect we fetch data and store it on the component state. Here we updating all the data once new block is produced, because the new data may be pushed only with the new block production. So here we use effect that depends on the current protected block number. So the core component of every page is here. It registers the game config, receives the cover image. Inside this component we have the game UI that displays all the things we see in the game. So here is the rules section. Here is the game status that shows either it's guessing or hiding state now. We have the user score that displays the score fetched from Upchain. We have the suggestion to make an action to either guess the number or to enter number to hide. We have an input that receives the number from user and set it in the component state. We have the button that executes the correct action based on current state. Let's see how it looks like in our browser. We'll open the game page, and here we can see the game. Now it looks like a real game. It has the user interface and can be played with someone who wants to play with you. Here I'm entering a number like 7 and hiding the number. A hide transaction is triggered. I sign it. And now game state is guessing. Let's first try the incorrect guess, like 6. I'm tapping the guess number button and I can see that a toast says that number is guessed incorrectly. I can try different numbers like 2 and it's all the same, number is guessed incorrectly. When I enter the correct number like 7 and tap the guess name, I can see the transaction, so I guessed the number correctly. I sign the transaction. We can see in the Upchain logs that there is a transaction executed on Upchain. And as I guessed correctly, I have score 1, so every time user guesses correctly, the score is increased. So this is our game. We implemented it from scratch. It's a pretty basic game, but if you're interested in building improvable games, you can implement something much more complicated and interesting. If you're wondering what you can implement with ZkNoid and Mina protocol, we have a list with ideas you can find in our blog and Twitter. If you're interested in further development with ZkNoid, We have a lot of infrastructure for building games. We have such things as session keys, allowing to create a local session that will sign all the transactions, so you don't need to confirm all the transactions in your game. We have cards engine, allowing to easily build any card game. Now it's showcased with poker game. We have leaderboards, recursive proofs. We have random manager, allowing to easily generate randomness in your game to make some initial level setups, to generate some loot. We have a lobby manager and matchmaking, allowing to make multiplayer games so opponents can find each other in the game. We have commit reveal scheme for the like games, so you can easily implement your own like game like Thimblerig. We have bridge and other infrastructure stuff in our SDK. You can easily reuse and build your own game.